Welcome you all to my video lecture series. This is the continuation of power method. In this video, we will discuss how to find all the eigenvalue and the respective eigenvectors using power method, particularly if it is 3 by 3 matrix. So come to the problem. Already in the previous lecture, we have discussed, I have taken one 3 by 3 matrix and 2 cross 2 matrix also to find the dominant eigenvalue alone. But here I'm going to find the dominant eigenvalue for the given matrix. This one part, this is the only part we have done in the previous video, but additionally we are going to do some other thing. Also find the least root, least latent root, eigenvalue, characteristic value, latent root, everything same. Okay, so least eigenvalue and the third eigenvalue also. That means what? What they're asking? Find all the eigenvalues. That is what simply there. Instead of asking in a single line, they're asking like that. Okay, right. So come to the problem. Just in as usual way, we are assuming the eigenvector x1 equivalent to non-zero column vector. It should be 1, 0, 0. Here you can assume 0, 1, 0 or 0, 0, 1 also. There won't be the issues here. Right. Now multiply A into x1. So A matrix into x1. You know how to do the multiplication. It should be row with the column wise. It will be, what will be 1 plus 0 plus 1. Sorry, 0. And then 1 plus 0 plus 0 and then 0 plus 0 plus 0. So this is what you will get. So 1, 1, 1. So dominant eigenvalue, numerically largest value you have to take as common. Any one, both are same, any one of the place you can take as common. Right. So 1 I have taken as common here. So 1, 1, 0 again. This is my new eigenvector x2. Now I have to multiply with the a into x2. You know very well it is the iteration process. How many times we have to continue the iteration? There is no restriction whether we have to continue such much time, 2 times or 3 times only, until the eigenvalue, it has to converge. Until that, you have to continue the iterative process, right? Now do the matrix multiplication, A into x2, A into x2. I will get this. So dominant, numerically largest value is 7. I have taken 7 as common, then which is equivalent to 7 into x3. This is my new eigenvector. Again, multiply by new eigenvector x3. This is my x3, A into x3. So 3.6 is the numerically largest value. Take that as common. So 3.6 into 1, 0.5, 0. Here I fixed it to one decimal place. Suppose in your exam, if they're asking, accordingly you have to fix it. Clear? Right. So this is my new eigenvector x4. Now do with A into x4. A into x4 equivalent to this. This is my new eigenvector. Yeah, this is my new eigenvector. Here, the dominant value, the largest value is numerically largest value. Note that word. Numerically largest value is what? 4. 4 we are going to take as common. Good. Then this is our new eigenvector x5. Do with A into x5. A into x5. It's again 4. So it's converging here. Previous also 4. Now also it is 4. So um, the eigenvalue, the dominant eigenvalue, using power method only we can find the dominant eigenvalue first. And the other things also I explained, least eigenvalue, that and all other part of that concept. Right. So dominant eigenvalue is 4 and its corresponding eigenvector is 1, 0.5, 0. Suppose if you are taking 2 decimal or 3 decimal, the iteration will increase. Here I fixed only what? Only one decimal place. Clear? Right. So next, one eigenvalue I found and eigenvectors also over one eigenvalue and its eigenvector. Next, two eigenvalues, rest of the eigenvalues. They asked to find all the three eigenvalues. How can I find the next eigenvalue? I have given the steps already in the in my previous video. What are the steps? First, to find the smallest eigenvalue of A. How to do that? First step, find the largest eigenvalue of A. Second one, we have to form a matrix B in terms of A minus lambda 1 into I. So already we know the given matrix is A minus lambda 1 just before we found using the power method, A minus lambda 1 to I. Next, the third one, find dominant eigenvalue of B. Clear. So here also find the dominant eigenvalue. This is dominant eigen. To find the smallest eigenvalue, first step is over. Already we found that. Find the dominant eigenvalue of A. Using that will be lambda 1. Using that lambda 1, form a new matrix B equivalent to A minus lambda 1 into I. Thereafter, this is my new matrix B. Find the dominant eigenvalue again for B, because using power method we can do that one alone. Power dominant eigenvalue only we can find. What is the fourth one? If you want to find smallest eigenvalue of A, which is equivalent to, what will be dominant eigenvalue of B plus lambda 1. So look at that this. If you want to find eigenvalues for A, take this value to the left hand side, B plus lambda 1. It will come like that, B plus lambda. Dominant eigenvalue of B we found in the third step, that plus lambda 1 will give the next smallest eigenvalue. So using the two eigenvalue, we have to use the trace concept, sum of the eigenvalue equivalent to sum of the main diagonal element concept, to find the third eigenvector. Okay, let us see how to use the, or how to find the smallest eigenvalue now. What are the steps involved? First step over, dominant eigenvalue of A we have completed. Next we have to form the matrix B. After form the matrix B, we have to find dominant eigenvalue of B. After that, that dominant eigenvalue plus lambda 1, if I am adding, I can get the second least eigenvalue of A. If you know two eigenvalues, easily we can find the third eigenvalue. This is what the procedure we are going to do here. Right. Now, what is our aim? We have to find the dominant eigenvalue of B. We have to form a new matrix B. Come to the point. To find the least eigenvalue, we have to form the new matrix B is equivalent to A minus lambda 1 into I. Lambda 1 is we found in the previous step. Lambda 1 equal to 4. So B equivalent to this minus B equivalent to A minus lambda 1. Lambda 1 is 4. 4 minus I. So 4, 4. In the diagonals, it should be, you have to multiply with the constant. Then I will get the new matrix. This is my new matrix B. Now what I have to do? Try to apply the power method to find the largest eigenvalue. Dominant eigenvalue for B. This is what my B. Okay. We can assume the same eigenvector 1, 0, 0. What you have taken there, you can proceed in the similar way. So let y1, already we have chosen x1. To understand the concept easily, I'm going to consider now that as y1. So y1 is equivalent to 1, 0, 0. I'm assuming b into y1 I am multiplying. So b value is this into y1. So the multiplication will give minus 3, 1, 0. So this will be what? What would be? Which value you have to take as common? Yeah, this is the important place. In the previous problems, the total positive value had taken largest value. So you won't get any confusion. But what about now? Minus 3, 1, 0. What is the largest value? Simply, if you want to say, it is 1. But uh, as I told you already, here we have to take a numerically largest eigenvalue. So what is numerically largest? Numerically only, not so we have to bother about sign. So it is 3. Minus is there. So take that element, entire thing as common. Minus 3 into 1. 1 by minus 3. Sorry. Yeah. 1 by minus 3 is 0. In that way, we have to do that. Then what will be? So minus 3 if I taking common, 1 minus 0.3, 0. So this is B1. This is new matrix Y2. Now I have to multiply B by 2 until the lambda is going to converge. Clear? I hope you have understand now. Right. Now by2, b into y2. Proceed in the similar way. My largest eigenvalue now it is 4 minus 4.8. Take that as common. I can get the new eigenvector y3. Now multiply by y3 because 4.8 previous is value is different, so it's not repeating. By3 will be this 4.8. So previously we got a 4.8 only. We can stop in this step. So it is repeated. So now dominant eigenvalue of B only we are finding. Dominant eigenvalue of B is this. Now we have to find smallest eigenvalue of A. How to do that? Dominant eigenvalue of B plus lambda 1. Then what will be? Minus 4.8 plus 4 is equal to minus 0.8. Am I right? So this one only, lambda 3. Now smallest eigenvalue I am going to take that as lambda 3. So lambda dominant eigenvalue of B I am writing is lambda B plus lambda 1 is will be, so lambda 3 equivalent to minus 0.8, and we know lambda 1 is equivalent to 4. Then how can I find the third eigenvalue? We know the property lambda 1 plus lambda 2 plus lambda 3 is equivalent to trace of A. Am I right? We are going to use this concept only to do that. Third eigenvalue via trace concept we are going to do. Lambda 1 plus lambda 2 plus lambda 3 is trace of A is equivalent to 6. Then lambda 2 we have to find lambda 1 is 4, lambda 2 is, lambda 3 is minus 0.8. Clear? Right. So if you're substituting that 2.8, so lambda 1, lambda 2, lambda 3. Guys, important thing here, it is not accurate. So in my all my video lectures, I used it to say we can watch other videos also. Using numerical way, we can find approximate solution alone, not accurate one. Nearer to accurate we can find, but it's not accurate. Okay, right. That's it, guys. This is the way to find all the eigenvalues. I hope you understand. For more understanding purpose, I have taken one more problem. Find the dominant eigenvalue and the least eigenvalue and the remaining eigenvalue. Means all the three eigenvalues we have to find. My given matrix A is this. Assume x1 equivalent in as usual way 1 0 0. Find EAX1. 3 will be the largest value. 3 I am taking as common. This is my new x2. Multiply AX2 now. A into x2 is equal to this. My largest eigenvalue, numerically largest eigenvalue is 3.6. Take that as common. Then I will get new eigenvector x3. A into x3. Do that. 5.7 I am getting here. Then multiply by another x4. 6.4. It's not repeating. Again ax5. 6.2. Again it's not repeating. Multiply by again here dominant eigenvalue, the largest eigenvalue is 6.2. Numerically, if it is negative sign also, you have to take that only as common. If it is negative sign or positive sign, no need to bother. We have to take the maximum value, largest value. Clear? Right. Now new x6 is 6. Thus multiply that. A into x6 equal to 6 we are getting. Right. I think it's going to converge. After a few more iterations, to try to practice uh, uh, one or two more iterations, you will get again the repetition 6. So therefore, dominant eigenvalue lambda 1 equivalent to 6, and the eigenvector will be this. Now our aim is to find least eigenvalue. How to find least eigenvalue? I have given the steps. We have to form a new matrix B, and then we have to find dominant eigenvalue of B. Then dominant eigenvalue of B plus lambda 1 will give smallest eigenvalue, lambda s. Lambda s means smallest eigenvalue. Clear? Right. Now B, I am going to form a new matrix B. It will be this. Now, yeah, B equivalent to A minus lambda 1 into I. Lambda 1 is 6. 6 into I. I will get this is what my new matrix B. Right. Now I have to find dominant eigenvalue of B using power method. Assume y1 is 1 0 0. Multiply B by 1. I will get this. Now look at that. Largest. Now largest is not 3. Numerically largest. Including the sign, you have to take as common. Only do not take, as I told you already, we won't consider negative sign. Some people what they will think, so we no need to take minus sign as common. So it's not like that. It's not the case. So you have to take that element, whatever the element, maximum element is there, largest element is there, including sign you have to take as common. So this is what y2. our new eigenvector. Do by2 minus 7 is our largest eigenvalue. We are taking that as common. Again, minus 7.5 is the largest one. Proceed in the similar way. We have to do the iterative process. Continue the iterative process until get the repeated values. Minus 7.8 is now this is y5 is new eigenvector by5. 8 we are getting 7 after 7.8. by6 again we are getting 8. Clear? So it is repeating. So in the previous case, one or two iteration will get more. So you just practice over one, okay, until get the repeated values. Suppose if you are getting some minus 7.8, 7.9 also, if it is repeating, you can stop there. Here I fixed to the one decimal place. That's why I have rounded the value. So it is 8. Right. Now minus 8, it's converging. So lambda b means dominant eigenvalue of b is 8. Using that, how can I find lambda 3 equivalent to dominant eigenvalue of b plus lambda 1? So will be minus 2. This is lambda 3 is minus 2. Lambda 1 is 6. How can I find the third eigenvalue? Sum of the eigenvalues is equivalent to sum of the main diagonal elements or trace of A. Right. Now lambda 2 equivalent to trace of A minus lambda 1 minus lambda 3. I'm getting 3. That's it. This is the way to find